Hey Math 202 students, let's knock out one more area between curve problem. Find the area of the region bounded by the curves y equals 1 over x, y equals x, and y equals 1/4 x. And we're assuming in this case that x is greater than 0. You have to watch out for the domain of 1 over x, right? Not allowed to divide by 0. If we let x equal -0, as you'll see from the graph, nothing good would happen. We wouldn't have any extra closed bounded region from that. So we're going to start off the same way we always do, and we're going to draw the graph, sketch the curve. Y equals 1 over x, we should be familiar with that one. Y equals x, I hope we're familiar with that one. And y equals 1/4 x. Same sort of thing, but a lower slope. So I hope that we can see here that we have a closed bounded region. And it's a worthwhile question to ask for the area of said region. The thing that's a little bit different from this problem, from the previous problems, is that here, if you look at the region, you can tell that there is some number c that denotes a split in the region. But the bottom curve is actually the same. The upper curve actually changes. So just keep that in mind. This is an example of a situation where you really need to sketch the curve in order to see what's happening. So just to show you where we're going to go, the area under the curve is going to equal the integral from, well, a to b of what looks like x minus 1/4 x dx, and then plus the integral from, actually I'll call this guy maybe, a to c, and then the integral from maybe c to b of, it looks like 1 over x minus 1/4 x dx, right? And we have to figure out what's a, we have to figure out what's b and what's c, right? Now, I suppose technically speaking, maybe just looking at the graph, you can tell a equals 0. I did say x equals 0. Maybe I need to adjust this a little bit for y equals 1 over x. X is greater than or equal to 0 otherwise. Just so that we do, in fact, have a closed region right there. Now, again, we don't know a equals 0, but it turns out it's going to equal 0, right? How would you find that out? Well, if we're interested in finding this area, then set those two curves equal to each other. To find a, let x equal 1/4 x. So x equals 0, which implies that a equals 0, right? To find c, we're going to do the same sort of thing, right? Here it looks like we're going to let x equal 1 over x. Well, that implies that x squared equals 1, x squared minus 1 equals 0. Well, you can see where we're going with this. And -1, not exactly what we're interested in right now, right? That's not in our domain. Okay? So c equals 1. And, of course, to find b, we do the same thing. Looks like we're going to let 1/4 x equal 1 over x. All right, and some similar trickery here. 1/4 x squared equals 1. I think we can see we're going to get 1/2 x minus 1, 1/2 x plus 1 equals 0. And that implies that x equals, I guess that's 2 and -2. Again, -2, not really going to help us. And then that implies that b equals 2. And that makes sense, right? You'd want a to be less than c and c to be less than b based on our sketch, right? Right. So what we have then is that the area under the curve is the integral from 0 to 1 of x minus 1/4 x. You can write that as 3/4 x if you wish. And then plus the integral from 1 to 2 of, what is that, 1 over x minus 1/4 x. Right? And then you just do both these integrals out. Nothing all that difficult or complicated. Just remember that the integral of 1 over x is ln of x, right? You don't need the absolute values because the domain is only positive, right? 1 to 2. Right? The integral of 3/4 x is that, okay. Plus ln of x minus 1/8 x squared from 1 to 2. And then that's going to equal 3/8 plus ln of 2 minus, I guess that's 1/2, right, when you plug in 2 for x squared. Remember that, I'll do it down here. ln of 1 actually equals 0. Right, don't forget about that. But also you plug in 1 for x, right, for x squared, and you get 1/8, right? So just be a little careful about that, right? So it looks like we're getting 3/8 plus 1/8 minus 1/2. I think that all cancels, right? Just note that this, and this, right, they cancel out. This cancels out because it's 0. So it looks like our answer is ln of 2. And ln of 2, by the way, is a little bit less than 1. So that's how you do that one. So again, similar sort of problem, but just be a little bit careful with your, with the bounds for your integral and with the upper bounds for your region. Thanks for watching.